Hello, AP Calc students. I'm going to go over some of the answers to the slope field homework so that you can know some of the things you got right and some of the things that you still need to work on. First of all, great job on doing the homework. I hope the video was helpful, and there will be more videos starting this afternoon from AP College Board, so we'll have to see what those are like. So on your slope field homework, I think you all did fine on number 1 where you had to draw the slope fields. You just draw little tick marks for the different slopes. For number 2, it was matching, and the answers were, so for number 2, we had 1, 2, 3, 4, 5, and 6 graphs. And you had to match the equation to the graph, but these were the equations of the functions, so you needed to find the derivatives of the functions so that you could match it to the slope field. So here are the answers to number 2. Number 1 was D, 2 was G, this was E, H, C, and A, and the other 2 were not used. Okay, that was the answer to number 2, so you can check your work there. And for number 3, you had 3 graphs, 1, 2, 3, and for this one, you were given the differential equation already. You didn't have to take the derivative. So for this one, the answer was D, A, and B. I think mostly you guys did okay on those, but there's the answers to those. If you want to, if you have more questions on that, make sure and ask me. Number 4 for part A and part B, you guys did great drawing the solution curve through there, but now let's look at part C. Okay, for number 4. It says approximate y of negative 3.1 using the equation of the tangent line. What they're wanting you to do is this equation is some curve. We don't know exactly what it is. It might look like the one that we drew like right there. It might look like the one that we drew right here. We don't really know exactly what the curve is, but at negative 3.1, let's say it's about right here. There, we want to know what the y is, but we don't know what that is. We don't know the formula for the curve. So instead, we're going to find the formula for this line right here, the tangent line, and we're going to take a number on the tangent line and use that to approximate the y value for the curve. So that's what we're trying to do. Tangent line, that means we need to find the equation of a line. To find the equation of the line, you need a point, which they gave you, and you need a slope. How do you find a slope? A slope is a derivative, and the derivative is x plus y. That's what they gave you up in the equation. So we're going to take our numbers right here and substitute them into there, and we're going to get the slope equals negative 3. So the equation of the tangent line is y minus 0 equals negative 3 times x plus 3, or y equals negative 3 times x plus 3. So that's the equation of the tangent line. Now we're going to use this to approximate y of negative 3.1. And we're going to do that by substituting in negative 3.1 for x. And that equals, that equals 0.3. Approximately. That's our approximation. So when it asks you for an approximation using a tangent line, You need to make the equation of the tangent line and then substitute in the value that they ask you for. That's called a linear approximation. Sometimes there will be linear approximation problems on the AP test. I have no idea what this test is going to look like because there's not going to be any multiple choice. So I really have no idea of what the problems are going to look like. Hopefully in the next week, the AP College Board is going to put out more information about that, and we'll have a better idea. So that was 4C. Now let's look at 5. We're finding the general solution. We'll start with 5A to the differential equation of dy over dx equals x e to the y. So in order to do this, solve a differential equation, it asks you for a general. That means there's going to be a plus c somewhere. We have to separate the variables. We're going to put all the y's over here, and we're going to put all the x's over there. So to get e to the y over here, it's going to have to be 1 over e to the y dy equals x dx. I'm going to write 1 over e to the y as e to the negative y, because that's easier for me to take an integral of when it's e to the negative y. Now, this is like e to the u, where u equals negative y, du equals negative dy, so negative du equals dy. So we would have to write this as negative e to the u du, and that would be the integral of e to the u is e to the u. So that's going to be, and u equals negative y, negative e to the negative y. That's this side of the equation. This side over here is going to be x squared over 2 plus c. So I'm going to bring that down to here. And now I need to solve for y. So I can't take the opposite of e is going to be ln, but I can't do that yet because of this negative. I have to get rid of it first. So I'm going to multiply everything by negative. So I'm going to get e to the negative y equals negative x squared over 2 plus c. And I can just do plus c because now that's a different c. Now, let me erase this. Whoops. Now I can take ln of both sides. Okay, ln of e to the negative y is negative y. And over here on this side, I have ln of negative x squared over 2 plus c. And am I done? Do I have y equals something? Not quite, because I have this negative out here. So I'm going to write it as y equals negative ln of negative x squared over 2 plus c. And that is my answer for part A. Some of you were very, very close to that. And someone may have actually got it. I can't remember if you got all the negatives straight. Okay, that was part A. Part B, you don't have to do, I'm sorry. Part B would be an inverse trig function, an integral of an inverse trig function. We didn't do those. So you do not have to do part B, but you had some good ideas for part B. So those are the answers to the slope field homework, and you can check your work if you have some questions on those. I'm going to be posting the link to the AP video. It goes live this afternoon at 2:30, and then after that you can watch it whenever you want, and I will give you some practice problems to work on. It's going to be on differential equations, so maybe kind of like this problem right here. We'll have to wait and see. So be checking Google Classroom, because that's where I'm going to be posting the links to the videos and the homework papers.